All right, so this third video in solving trigonometric equations, again, really isn't any different. We're just going to be looking at a few more complicated examples. So here we're trying to solve this guy on the interval 0 to 2 pi, so a finite number of solutions in radians. Now, one of the things that I noticed right off the bat is how I have a double angle and I have a couple single angles. However, if I look real carefully at this guy, this type of problem actually suggests converting both into double angles. So follow me here on this. I'm going to leave the first term alone, and then I'm going to have a minus 2 sine of x cosine of x squared equals negative 1. So I really haven't used an identity yet, but notice I went ahead and I just rewrote this guy to look like this. And they're both the same. And in recognizing that, there sits your double angle identity. So 2 cosine squared 2x minus 2 sine squared 2x equals a negative 1. And if I divide everything by 2, I'll get cosine squared of 2x minus sine squared of 2x equals a negative 1/2. And here sits another identity. So cosine squared minus sine squared. This one is actually going to turn into cosine of 4x equals negative 1/2. Remember, the original identity said that cosine of a double angle equaled cosine squared of x minus sine squared of x. So in our example, this was a 4, which means we need to multiply each of these angles by 2. So cosine squared of 2x minus sine squared of 2x gives us the cosine of 4x. And now, again, we're back to where we have an easier problem to solve. Cosine is negative. Cosine is negative in quadrants 2 and 3. So this would be a negative 1. This would be a 2 and a 2, and a square root of 3 and a negative root 3. So in radians, we've got a pi over 3 as our reference angle. And we'd want to be able then to give this angle and this angle. Now, thinking ahead a little bit here, again, we're going to have a finite number of answers, but no matter what my answers are, they're going to start out as 4x equals something and 4x equals something else. Once I identify that, my next step is going to be to divide by 4, which significantly decreases the actual value. And if we have to somehow get all the way up to 2 pi, chances are I'm going to need to take full advantage of having k's in this step so that I can then figure out the specific numbers that will keep us in the 0 to 2 pi interval. So the first answer that we have here is going to be 2 pi over 3. And again, I'm just going to write the 2k pi on there to be safe. The next one, the larger angle, would be the 4 pi over 3 plus 2k pi. And then, as we talked about, we'll divide everything by 4. So the first answer gives us x equals, and then when I divide that by 4, I'm going to get a pi over 6 plus k pi over 2. And then for the second one, I'm going to get an x equals pi over 3 plus k pi over 2. Okay? Now, again, I realize I'm given a finite number of answers, but notice how I've significantly decreased the 2 pi over 3 to pi over 6 and the 4 pi over 3 to pi over 3 when I divided by 4. So now, to keep things organized, I'm going to come back over here and say, all right, whoops. When k is 0, I'm going to get an x equals pi over 6, and I'm going to get an x equals pi over 3. When k is equal to 1, I'm going to get two different x values, both of which will still be in the interval. So when k equals 1, I'm going to get a 2 pi over 3 and a 5 pi over 6. Still need to go further. when k equals 2. Looks like I'll end up with a 7 pi over 6 and 4 pi over 3. When k equals 3, I'm going to get x equals 5 pi over 3 and x equals 11 pi over 6. Now notice if I go any further, if I let k equal 4, and then I would encourage you to try this, if you let k equal 4, you're going to exceed the 0 to 2 pi interval. So these 8 answers right here would be the answer for this particular problem with these given instructions. All right, so in this example now, I'm actually viewing this almost like a quadratic equation. I've got cotan squared, I've got cotan to the first. If the coefficients allow, I might be able to factor it. And for the record, we're going from 0 to 360 here. But unfortunately, it's not factorable. So since it's not factorable, we'll need to either complete the squared, use the quadratic formula. So I think the quadratic formula would probably be pretty easy. Actually, completing the square would be pretty easy too. But for what it's worth, I'll use the quadratic formula. So cotangent of theta equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's going to be 4 plus or minus 16 minus 8 would be the square root of 8. So 2 root 2 over 2, which means that cotan of theta would equal 2 plus or minus the square root of 2. And tangent of theta then would be 1 over 2 plus or minus root 2. Now, clearly this is not a special triangle that we recognize, so it's probably not a bad idea at this point to go ahead and split this up. I'm going to view it as tangent of theta equals 1 over 2 plus root 2, and tangent of theta equals 1 over 2 minus root 2. This way I can proceed with the same line of questioning. I know the square root of 2 is approximately 1 point something, so in this first problem here, tangent is positive still, okay? So tangent's positive in quadrants 1 and 3. And then over here in the second part, since again the square root of 2 is approximately 1 point something, this actually says tangent is positive as well. Now I'm going to get a little carried away and actually redraw the same thing, quadrants 1 and 3. And we're understanding that for both of these, we're going to need to give this angle and this angle right here. Okay, that angle and that angle. Now, this is clearly a calculator problem at this point. And this suggests that theta equals the inverse tan of 1 over 2 plus root 2. Now, when we punch this in our calculator, we're going to get an answer. In this first one in particular, we're going to get a 16.3 degrees. Now, that's clearly the angle that I have marked right here because I know that inverse tan is defined in quadrants 1 and 4. So to find this other angle, looks like that I'm going to need to add 180 to it. So if I take that plus 180 degrees, I'll end up with theta equals 196.3 degrees. So for that first picture, these are the two answers you would need to give. Now for the second one, once again, theta equals the inverse tan of 1 over 2 minus root 2. Punching this into a calculator, remembering that inverse tan is going to spit out an angle in quadrant 1 in this case, we're going to get 59.6 degrees. Similar to the last one, if I add 180 to get the other missing angle, theta is going to end up being 239.6 degrees. So these four answers would be the answer to the original problem.